Welcome to Deep Research TV, where we dive deep into the most mind-bending questions of science and the universe. Imagine this. You step into a machine, press a button, and suddenly you're standing in ancient Egypt watching the pyramids being built. Or you jump forward to the year 3000 to see flying cars and colonies on Mars. Time travel has fascinated humans for centuries, from H.G. Wells' classic novel to blockbuster movies like Back to the Future and Interstellar. But is time travel actually possible, or is it just science fiction? Today, we are going to explore the real science behind it, based on Einstein's theories, quantum mechanics, and cutting-edge physics. Let's find out. First, let's clarify what we mean by time travel. There are two types: traveling to the future and traveling to the past. Surprisingly, traveling to the future is not only possible, it's already happening, and science fully supports it. This comes from Albert Einstein's theory of special relativity, published in 1905. Einstein showed that time is not absolute. It's relative to your speed and gravity. The faster you move, the slower time passes for you compared to someone standing still. This is called time dilation. A real-world example is astronauts on the International Space Station. They orbit Earth at about 28,000 kilometers per hour. Because of their speed, time moves slightly slower for them than for us on the ground. When astronauts return after months in space, they have aged a tiny fraction, lessly traveling a few milliseconds into our future. But we can go much further. If you could travel close to the speed of light, 99.999% of it, time dilation becomes extreme. For you on the spaceship, only a few years might pass, but on Earth, centuries or even millennia could go by. This is forward time travel, and it's completely allowed by the laws of physics. No paradoxes, no violations, just you arriving in the distant future while barely aging. General relativity, Einstein's 1915 theory of gravity, gives us another way: gravitational time dilation. The stronger the gravity, the slower time flows. Near a black hole's event horizon, time almost stops relative to the outside universe. In the movie Interstellar, this was shown dramatically. Hours on a planet near a black hole equaled decades back on Earth. Again, this is real physics. GPS satellites already account for both types of time dilation to give us accurate locations. Without corrections, your maps would be off by kilometers every day. So, forward time travel, yes, definitely possible in principle. We just need incredibly high speeds or extreme gravity, which we don't yet have the technology for. But backward time travel, going to the past, is where things get really controversial. Many scientists say backward time travel is impossible because of paradoxes. The most famous is the grandfather paradox. If you go back and prevent your grandfather from meeting your grandmother, you would never be born. So, how could you go back to prevent it? This creates a logical contradiction. Stephen Hawking took this seriously. He proposed the chronology protection conjecture, suggesting the universe has built-in safeguards to prevent backward time travel. He even threw a party for time travelers in 2009. But didn't he announce it until after the date? No one showed up, which he jokingly called experimental evidence that time travel isn't possible. But some theories do allow backward time travel, at least mathematically. One idea is wormholes, hypothetical tunnels in space-time that connect distant points or even different times. Einstein and Nathan-Rosen first proposed them in 1935 as Einstein-Rosen bridges. Physicist Kip Thorne, who consulted on Interstellar, showed that if wormholes exist and could be kept open with exotic matter stuff with negative energy, you might traverse them to emerge in the past. The catch: we've never observed a wormhole. Exotic matter might not even exist in the quantities needed, and quantum effects could make traversable wormholes unstable or impossible. Another idea comes from rotating universes, or cosmic strings, massive, thin relics from the Big Bang that could warp space-time dramatically. Physicist Frank Tipler showed that a sufficiently long, spinning cylinder could create closed time-like curves, paths in space-time that loop back to the same moment. Travel along one, and you're in the past. Kurt Gödel found similar solutions in rotating universes. But again, our universe doesn't rotate that way, and building a typeless cylinder would require infinite length or godlike engineering. Quantum mechanics adds more twists. Some interpretations of quantum gravity, like certain versions of string theory or loop quantum gravity, suggest time might not even be fundamental, it could emerge from deeper realities. Physicists like Carlo Rovelli argue that time is an illusion at the quantum level. There's also the many worlds interpretation of quantum mechanics. If every quantum event splits the universe into parallel branches, then time travel to the past might just mean jumping to a different branch where the past is slightly altered. No paradoxes, because you're not changing your own timeline. Recent ideas involve quantum teleportation and entanglement. In 2014, physicists proposed that quantum states could be sent backward in time using entangled particles, though only information, not matter. But even that remains theoretical. What do today's top physicists think? Brian Greene says forward time travel is real, backward is doubtful. Sean Carroll believes closed time-like curves might be possible but would require extreme conditions we'll never achieve. Michio Kaku is more optimistic, placing time travel in his Type 3 civilization capabilities far beyond our current level. Experiments. Particle accelerators like the LHC smash particles at near light speeds and see time dilation effects, but no time travel. We sent particles backward. In a sense, antimatter particles like positrons experience time in reverse from our perspective, but that's not useful for macroscopic travel. So, where does this leave us? Forward time travel is scientifically established and will likely become practical one day with advanced spacecraft or gravity manipulation. Backward time travel remains speculative, mathematically possible in some models, but probably forbidden by undiscovered laws of physics or sheer impracticality. The universe seems to protect its own history. As Hawking said, the best evidence we have that time travel is not possible is that we have not been invaded by hordes of tourists from the future. Yet science keeps surprising us. A century ago, no one thought black holes or the Big Bang were real. Now they're confirmed. Maybe one day we'll crack quantum gravity and find out definitively. What do you think? Is time travel waiting for us in the future or forever out of reach? Drop your thoughts in the comments. Like if you enjoyed this deep dive, and subscribe to Deep Research TV for more explorations of the universe's biggest mysteries. Until next time, keep questioning reality.